Hello dear students, welcome to you for the power system operation and control class. Previously we have seen regarding the introduction of this subject where we have seen the different states of the power systems, alert state, emergency state, like that, which you are studied in the your previous semester subject PSA 2 also. Those things we have seen. Now directly we will enter to the supervisory control and data acquisition. What is the supervisory control and data acquisition? You know that Scada, commonly we are calling Scada. What is this Scada? This Scada is nothing but it's a supervisory control and data acquisition of the different equipments which is geographically dispersed in the power system. Means somewhere generating stations will be there, somewhere receiving stations will be there, in between kilometers of long transmission lines will be there. It may including the circuit breakers, supporting structures, many things, PT, CT, different things we are connected to these things. So this SCADA is giving the total supervisory control of these equipments as well as some amount of the data are stored. This SCADA consists of both hardware as well as software. In the previous decade, there is a remarkable progress is done in the performance, functionality, scalability and utility of this SCADA. SCADA is only for supervisory control and does not include the full control system. And there is a chances of some data storage. In electric power system, most supervisory systems are meant to provide operation with sufficient information and control capabilities to operate the power system in a safe and secure manner. So we will see what is the supervisory control system or what is the intention of the supervisory control system. Okay, so some of the typical supervisory system we will have. First one is SCADA. SCADA, you know, it's a system which performs traditional operations of data acquisition and control. Second one is SCADA bar AGC. SCADA is similar, which is having the supervisory control and data acquisition. Apart from that, AGC is having a capacity of the area control error calculation and monitoring the system frequency and also the tie line interchanges and performance of the economic dispatch. Apart from the traditional SCADA, the AGC's control action is included. This is called as SCADA bar AGC. Next is EMS. EMS is nothing but energy management system which incorporate all features of SCADA and also includes the other computations like load flows, state estimations, contingency analysis, etc. It includes the extensive capability of the record keeping and data exchange compared to the previous SCADA, which is having the extended capacity of the data recording. Next is DMS. DMS is nothing but distribution management system are meant to monitor and control the distribution feeder loads. DMS today includes the topology analysis and load flow programs that allow identification of the problems and restoration of services. Next is LMS. LMS is nothing but load management system. Is meant to manage the peak load and is useful for the demand side management. It can be standalone program or integrated into EMS and DMS. So it can be used as standalone or including DMS, EMS, LMS togetherly or integratedly we can use. The next one is AMR. AMR is nothing but automatic meter reading is incorporated into LM systems. So these are the some supervisory systems. Many times we are see the telemetry. What do you mean by telemetry? I told you there is a while explaining the SCADA. SCADA will transmit the data using telemetry, or data acquisition is done using the telemetry. How it is possible? What is the telemetry? Telemetry is nothing but it's a technique used in transmitting and receiving the information over information or data over a medium. Typical data in a power system are the measurement of the voltage, it may be the power flow data, or it may be the circuit breaker status, many things, it may be current, or this information is transmitted over a medium. See what is the voltage at the particular line, or what is the condition of the circuit breaker of the phase R, phase Y, phase B, like those things. It can be, it need to be transferred to the controller, or the person who is sitting at the station. It can be transmitted through cables, or using the telephones, or using internet and radios. There is a multiple options are there for us to get this data from the multiple locations. So this is the sending the data from the different stations to the main station using these cables, or telephones, or the internet. This is called as the telemetry. Next is data acquisition. What is data acquisition? It refers to the method used to control the information or data from the equipment that is being controlled and monitored. Not only collecting it is controlled as well as monitored. The data are forwarded via the telemetry system, as I told you now. It can be used by a cable, telephone, or a radio, internet. This information will be in the form of analog or digital form. So few things we need to collect it from the analog form as it is. Few things are we need to get it from the digital form. See, while knowing the voltage, we need to go for analog form only. If the circuit breaker status, we will be having with the digital form. So this data is obtained from either sensors, or meters, or actuators, or control equipments like relays, many things. So all these data are togetherly collected. So this is called as data acquisition. From this, above all the telemetry, data acquisition and all, we will give the definition for the Scada is Scada as a collection of equipment that will provide an operator at a remote location with enough information to determine the status of the particular piece of equipment, or an entire substation or power system, and cause actions to take place regarding that equipment or facility without being physically present at the location of the fault. So by this you will now come to know that this SCADA is a collection of the different equipments data. It is provided to a operator who is sitting at the remote location, and he is having enough information to determine the status of the particular equipment. So what to do, whether it is in fault condition, whether it is in good condition, or he can be done the control from that particular place only. So this is called as SCADA. Now we will see what are the different components of the SCADA. So while coming to the different components of the SCADA, so basically the SCADA systems collect information from the field or site from the equipments, and it is transferred to the central computer facility and display the information to the operator to facilitate the control or entire system, or the facilitate the control of the entire system from the central control room. In SCADA system, geographically displaced sites contains either remote terminal unit. It may be in few sites there will be remote terminal units. What is this remote terminal unit? It is nothing but a computer or a programmable logic controller, PLC, which controls the local actuators and monitor the sensors. The communication equipment allows the transfer the information to the operator from the RTU and PLC, and where the control center which we will be having the master terminal unit. This communication will be through the telephone, radio, or cable. So you will see this figure here, how the general SCADA configuration will be there. This is a control center where HMI, or it is called as MMI, human machine interfaces, or man machine interface, where engineering workstations are there. So there is a control server, that is SCADA MTO, master terminal unit, and communication routers will be there from the different method. There will be data are coming that will be taken there is a data historian. So this is togetherly called as control center, and this is the different ways of the data transfer. Either it may be switched telephone lines, or by radio, by satellite, or wide area network. See the different fields I am showing you. One field is connected with PLC, another one is intelligence electronic devices, another one is with RTUs. So this is a totally a one SCADA configuration. The major components of the SCADA systems are classified as: the first one is field instrumentation, second one is the remote station, third one is the communication network, fourth one is the central monitoring station, and fifth one is the software. First one, field instrumentation. So it refers to the sensors as well as actuators in the site, which the equipments are connected to the these sensors or actuators. It generates either analog or digital signals sorry are monitored by the remote station. So generated signals are conditioned will be compatible with RTU and PLCs at the remote station. Analog outputs of the sensors have standard industrial values like 0 to 5 volt, 0 to 10 volt, or 0 to 20 milliamps. Or digital outputs are referred as on-off condition, full or empty condition, open or closed condition. These are the field instrumentation, which is to collect the data from the field. These actuators or sensors are used there. Next is remote station. Remote station or field instrumentation is connected to the plant, substation, or equipment which is being monitored and controlled, is interfaced to the remote station to allow the manipulation of the remote site. The remote station may be an RTU or PLC. The RTU is a computer with good interfacing communication and flexible programmability. The PLC used in most of the companies or industries, it has got very good programmability. The modern PLCs also have the extensive communication features and radio units for use the SCADA system. The remote terminal units figure is shown in here. You can see there is a central bus where power supply, central processing unit, different memories, analog input module, analog output module, digital input module, and digital output module, which is connected to central bus where the modem is connected. There is a radio transmitter receiver through antenna it is going. Main RTU is containing this one, which is given to 240 volt AC source. There is a operating station. See, computer is there, programming terminal there. So different cables are used for transmitting things, and PLC is also there. So this is what the typical RTU unit, where how the remote terminal unit is working. Next, coming to the communication network, how it is communicated. The communication equipment needed to transfer the data from different sites. Commonly used communication medias are RS-232, RS-442, RS-485, or dial-up telephone lines, and dedicated landline, microwave, satellite, different X.25 packet protocols, radio via trunked VHF, UHF, many things are there. Cables are normally used in this one in factories, and are not practical for the system spread over the geographical areas. In one industry you may use the cables, but the geographical dispersed things we cannot use the cables. So we require there the satellite transferring or telephonic way we need to adapt. And the use of Ethernet on the rise since the when it is cheap. It has got one internal communication and access to the remote devices. Next, coming to the central monitoring station, where central monitoring station is a master unit of SCADA system. It is the charge of information collection from the remote stations, generating control actions for any event in the any event and generating reports. It could be just single computer or a network of workstations to allow the sharing information. The components of this central monitoring stations are MMI or HMI, which is man-machine interface or human-machine interface, and a mimic diagram of the whole system or the plant displayed on the operator. Display of RTUs with present IO reading, that is input output reading, window for alarms, and trending display, like your share markets, how the trends are showing, like trending, where what is happening, where all those things to be displayed. And coming to the Scada software, the software of Scada is based on the real-time database. The Scada software of the two different types. One is proprietary and another one is open. Proprietary software is developed by the companies to communicate with their own hardware. So we need to depend on the same company. But open things, if you use means, it can be available anywhere. So anyhow, after completion of this module, I will give you the notes. So in the next class, I'm going to teach you the how standard SCADA configuration will be there. If any doubts, you can message me in our WhatsApp group. Thank you.